the C in this is the C, so we to an integer so that we can increment it. So the C here is 0 plus 1, so it will be 1. And then so as here the second one, so we are converting again the enum value of the green, so we're making it 2, and then so on. So we do like the third increment here, value of C3, which is not part of the defined color number. So red is equal to 0, green is equal to 1, and blue is the 2. But C++ allows this because under the hood, enums are still treated as integers. So that's basically like one of the uh, flaws of the C++ in using this like safety concerns. So it's unsafe as enum should represent fixed values, and going beyond the defined range can lead to logical errors. So this is the number 5 of our exploration, problem number 5 of our exploration in enumeration types in C++. So we're going to do the number 6 problem that we're going to explore about the enumeration in C++. So this is the bitwise operations on enum. So we will perform the bitwise operations. In this is the or and end on enums. So here, this one. So we're going to is it the red and blue? We're using red or blue. So let's see if the C++ will allow us to do this. Okay, so as you can see the result here, so bitwise operation is here, and then the result is 5. So how does it happen? So C++, it did allow the bitwise operation on enums, so treating them as integers again, like which is useful with enums representing flags. So for example, we are combining the red and blue into a single value. So here, red and blue, so which is gives us 5. So but while is it legal, bitwise operations on enums should only be used when enums are defined for such purposes, so like flags, so as they don't make sense for typical enum use cases. So yeah, this for this one, it makes sense to just, like, for me, my takeaway allow this because it's this is useful in such purposes. So this is our number 6 problem exploration of enums in C++. So now we're going to continue the exploration of enums in C++. So let's try the switch case with missing enum values. So as you can see on the screen, we have here still the same, the enum color, and then we have some our case statement here. Color is red. So as you can see, we are missing blue. We're setting here C is equal to blue, but we're missing the we don't have the case for blue. So let's try if C++ will allow this. Okay, so there's no error, but program did not output anything. So so C++ did not throw an error when some enum values were missing from the switch, leading to unhandled cases. So why the instead of like throwing error, so in this case, so missing cases is switch statement switch statements are allowed in C++. So even though we are missing here, like as you can see, the blue one case, the blue is not here. So and then also enums are treated as integers. Remember, like from the first exploration that we had, the first problem, I told you that enums are treated in C++ as integers, and it's up to the programmers to handle values correctly. So you have to be very careful because it's not throwing an error, so you will not know, like it will become as one of that unhandled cases. And gives the programmer flexibility to leave out cases, even though like for programmer this can potentially lead to bugs if not done carefully. So yeah, you just have to make sure that so maybe in the future, if you will use this, if you will be using switch case statement, you have to ensure that all enumeration values are handled. Means you can add like a default case, or you can enable a compiler warning, so to have like a heads up, or just for best practice to avoid such unhandled cases enumeration in the C++ language. So that's our exploration of switch case with missing enum values. Okay, so let's do the number 8 example. Continue the explorations of enumeration in C++. So our number down to, like, this is the last third to the last examples of somewhat legal in C++. That's like have like concerns, safety issues. So here, so what if you will like forget break in a switch uh, conditions, like, so will C++ allow this? So as you can see here, we missed some break here. So we set C is equal to green. So here the program, we don't have a break, so we forgot. So we don't have a break from red. So here we don't have a break in red, so it will just go to the next one, the C, the green. I mean the case for green, but we don't have a break again. Although we already have a match green. The C is equal to green, so it should like stop. But let's say for example we missed the break, like we forgot, and then just continue. So let's see if C++ will allow this. Oh, okay. Okay, so we have here colors green, colors blue. So that's our output. So C++ allow this, even though so we have two output, although we just have like should be here C is equal to green. So without break in C++, without the break, it did allow the fall, they call it the falls through. So means so in our case it's causing multiple cases to be executed. So here, although we have the C, so even though we have much, so here we have already, so we satisfy already that C is equal to green, but it did uh, continue until this hit this case blue, then break here. So um, omitting break so leads to unattended behavior. So where the switch continues will just execute until the, like here, and for our case here, until it did hit the break, so which is often